Hi everyone. In this session, we are going to learn about digital circuit design. This lecture contains logic gates, Boolean algebra, K-map simplification, combination circuit design, flip-flops and its types, and sequential circuits. First, we'll talk about logic gates. So in general, logic gate is a electronic circuit which performs logical operations. In general, the logical operations are known as AND operation, OR operation and NOT operation. AND operation is similar to multiplication process. OR operation is same as addition process. NOT is nothing but inversion. The gates known as AND gate, OR gate and NOT gates are used to perform this logical operations. Apart from this, exclusive OR gate is there. That gate is used to perform XOR operation. So simple logic gates are classified as OR gate, AND gate, NOT gate, NAND gate, NOR gate and XOR gate. As we said earlier, OR gate is a gate which is used to perform addition operation. That addition is called as logical addition. While performing logical addition, let us consider two inputs A and B. So the output Y is the addition of A plus B. If more than two inputs are given to one OR gate, it will be the addition of 1, 2, etc. up to n number of inputs. So let us consider in this gate OR gate, A and B are two inputs and Y is equal to A plus B. Here is the truth table of OR gate. OR gate, when we can give the input combinations as 0, 0, 0, 1, 1, 0 and 1, 1. 0, 0 means A and B both inputs are at low stage, low condition. 0, 1 means A input is at high condition and B input is at low condition. And 1, 0 means A is high and B is considered as low. 1, 1 means both inputs are high. In an OR gate, when any one of the input is equal to high, then output will be considered as high. So, any one of the input is high means we can write the output of OR gate as high. Now, next is the gate called as AND gate. We said AND gate is nothing but the gate which performs the logical operation which is called as multiplication. So, two inputs A and B is given as the OR gate. OR gate output Y will be the multiplication of the two inputs A and B. So, Y equal to A dot B. Here dot is called as the multiplication product. So, this OR gate, this is the symbol of OR gate, that is logical symbol. So, truth table of OR gate is when two inputs A and B both are 0, the output is 0 and both are 1, the output is 1. So, any one of the input to the OR gate is 0, the output will be 0. So, as said for OR gate, if any one of the input is high, the output is high. But in case of AND gate, if any one of the input is low, the output is 0 for AND gate. When both inputs are high, the OR gate output is high. Next is the NOT gate. It is a gate which performs the inversion operation or complementation. Here, this gate we should give only one input, that is the gate receives only one input and it gives the output as the complement of the input received. That is, A value is 0, that is the input received is 0, the output is 1, that is A complement. 0 complement is equal to 1. If the input received is 1, the output is 1 complement, that is 0. That is called as the NOT gate, function of NOT gate. So, the truth table of NOT gate is for 0, the output is 0 and for 1, for 0, the output is 1 and for 1, the output is 0. Next is the NAND gate. NAND gate is the contraction or the combination of NOT and AND gate. So, this bubble indicates the gate is the NAND gate. This is thing but the gate which is performing the operation which is called as NAND operation. So for two input 0 0, the output is 1. For one input A is 0 and B is 1, output is 1. For any input A is 1 and B is 0, output is also 1. When both inputs are high, output is low. So just reverse of that AND gate. So here when both inputs are high, the output is 0. Next is NOR gate. NOR gate is a combination of or contraction of NOT and OR gates. So here two inputs are A and B. So NOR output is A plus B the whole bar. So when both inputs 0 0, X and Y are A and B, let us consider the two inputs and both inputs are 0 0, the output is 1. When any one of the input is 1, the output is 0. This is the logical symbol for NOR gate. In general, NAND and NOR gates are called as universal gates. The reason these two gates are called as universal gates is because of these two gates we can do the logical operation of all other gates. That's why it is called as NAND gate. So XOR gate, for XOR gate the output is A XOR B. The operation is known as A B bar plus B A bar. So this gate is a gate with two or more inputs and output is only one output. The output of two XOR gates are when both inputs are high, the output is low. When both inputs are low, output is also low. When one input is high and another input is low, the output is high. So in general, Boolean algebra is one which performs the logical values, that is true and false values. It have true states high and low. Using Boolean algebra, we can perform Boolean operation, AND operation, OR operation and NOT operation. Boolean operators are used to combine Boolean variables and to perform Boolean operation. So OR operation is called as A plus B, that is A plus B. For AND operation, A and B, A into B. NOT operation is so A bar. So De Morgan's law, as per De Morgan's law, A plus B the whole bar is equal to A bar into B bar. A into B the whole bar equal to A plus B the whole bar. So Boolean algebra, the sum of product we can write this as minterms. So f of x comma y comma z is equal to we can write this as sum of products, that is minterms. So 0 0 0 is A bar, B bar, C bar, etc. up to 1 1 1 is A, B, C. So sum of product is nothing but the term related with minterms. So max terms are product of sums. They are the terms related with max terms. K-map simplification. This is one two variable K-map that consists of 4 terms, 4 cells, and 3 variable K-map which consists of 8 cells. So given circuit is the 3 variable K-map C, A and B, that is A and B, A, B, C are considered as 3 variables, and these are the way to write the K-map, that is 0, 1, 2, 3, 4, 5, 6, 7 is the way to write the K-map. So this is 2 variable K-map structure and this is 3 variable K-map structure, and 2 variable K-map structure consists of the cells, number of cells called as 4. For 3 variable K-map structure, the number of cells called as 8, and for 4 variable K-map, the number of cells is 16. So for this 2, 3, 4, etc. up to this number of variables can be calculated by 2 power 1, 2 power 2, 2 power 3 and 2 power 4, etc. like this. So this is the product of some simplification, and this is called as max terms. and similarly sum of products are there, that is also called as minterms. So next we will move to combination circuits. So combination circuit is the one which consists of no memory elements. So here the multiplexer, demultiplexers, encoders, decoders, half adders, full adders, half subtractors, full subtractors, and these all are called as the examples of encoder. So first example is multiplexer. So otherwise called as data selectors. So multiplex means many to one. So given from n number of input signal, so only one output is selected using some m number of select lines. So using this m number of select lines, that is data selector, only one line is selected. So the next is the inverse operation of multiplexer, that is called as demultiplexer. So the inverse operation, data distribution, is performed in demultiplexer. It means one to many, only one input is received using some m number of select lines. This n input number signal is converted to one output signal. So this is called as demultiplexer. Then encoder and decoder. So encoder is a digital circuit that performs the inverse operation of decoder, and here this encoder receives n number of inputs and produces m number of outputs. It is also a combination circuit that is used to convert the active input signal to the coded output signal. So there are different types of encoder: priority encoder, octal to binary encoder. So all are the general forms of encoders used. For octal to binary encoder, the given octal input is converted to binary. So that is called as octal to binary encoder. Here in case of decoder, it is similar to demultiplexer, but without any data input. So it is most used in digital systems for decoding the data. So demultiplexer or decoder same set of performing the same operation. So a lot of decoders are there. So 3 to 8 decoder receives 3 input bits and produces 8 output bits. Next is flip-flops. Simple kind of sequential circuit, that is combination circuit with memory, is called as sequential circuit. Flip-flop is one of the example of sequential circuit. There are different types of flip-flops available. One is RS flip-flop or SR flip-flop, that is set reset flip-flop, otherwise it is called as set reset flip-flop. Then D flip-flop or delay or data flip-flop, JK flip-flop. T flip-flop, otherwise called as toggle flip-flop. SR flip-flop, S is equal to set and R is equal to reset. When 0 0 is given as the input, output is no change, and 0 1 is given, it is called as 0 1 means S is equal to 0, 1 R equal to 1 means for R equal to 1, that means reset. Reset means the next state is 0. 1 0 means at a present set value is equal to 1 and reset value equal to 0. So for set value equal to 1 means that is called as set. The output is, here the output is 1. So 1 1 it is called as indeterminate state. For this state we can't tell what the output is. So in this SR latch, because of this indeterminate state, this latch cannot be used in sequential circuit design. Generally we will use JK and T flip-flop, that includes the toggle mode for analysis and design purpose of sequential circuits. So RS flip-flop, for S is equal to 0, R equal to 0, that is called as no change condition. For S is equal to 1, R is equal to 0, that is called as set state. So for set state, the output Q of T is equal to 1. For S is equal to 0, R equal to 1, that is called as reset state. For reset state, the output is equal to 0. For both cases, S and R is equal to 1, the state is called as indeterminate state. Indeterminate state means we can't able to tell what the output is, so output cannot be determined. D flip-flop is otherwise called as data flip-flop or delay flip-flop. So here this is a flip-flop which gives the given input as the next state. So D is equal to 0 means output is equal to, or next state equal to 0. For D equal to 1 means the next state is equal to 1. So this type of flip-flops, the given input is received at the next state. So the application of D flip-flop is, it is used in storage registers. So in case of JK flip-flop, it is same as set of RS flip-flop. So in this R here, this is called as reset, and J it is same as set of set. So J is equal to 0 means what is, in case of J is equal to 0 or K is equal to 0, that is no change. J is equal to 0, K equal to 1 means here reset is 1 means that is 0, output is 0. For 1 0 the output is 1, that represents the set state. And here in this case 1 1, it is called as toggle case. So here the output is toggled. We should consider the toggle condition. So that is J is equal to 0, J is equal to 1 and K equal to 1 means toggling. Toggling means changing from 0 to 1 and 1 to 0. Because of this toggling, we can use in counters frequency dividers. So T flip-flop or toggle flip-flop, J, K both are taken as a single input, and that input is named as T flip-flop. Otherwise it is called as toggle flip-flop. This toggle flip-flop, when 0 is given as the input, the output is Q of T, that is no change. When 1 is given, the output is Q complement of T, that is called as 0 to 0 means there is no toggle, so output is 0. 1 to 1 means in this case also there is no toggle, so output is 0. 1 to 0 and also 0 to 1 means here toggle is there, so output is 1. So that is called as T flip-flop, working of T flip-flop. Because of this toggle, it is used in counters design. Sequential logic circuits, remember past inputs and past circuit states. So because of its memory, it can able to remember the previous state. So present state, next state is considered in case of sequential circuit. So combination circuit with memory is called as sequential circuit. So in this memory elements can be flip-flops, delay elements, clocked flip-flops, etc. If clocked flip-flops are used, that is called as synchronous sequential circuits. If unclocked circuits or delay elements are used, that is called as asynchronous sequential circuits. So till now we have learned about the basic ideas and basic working of logic gates, then combination circuits and sequential circuits. Thank you.